Hi everyone. Let's illustrate net present value using this example. So what we have here is a forecast of net cash flows. This would be net, meaning inflows less outflows. And we've got a forecast of when those cash flows will take place. So we're assuming right now, that's today, period 0, we're going to spend $100,000. Okay, turn that into dollars so we know that this column represents dollars. And then, as a result of this project, business opportunity, whatever it might be, we think the net cash inflows will start off at $15,000 for the first year, then increase by $5,000 every year, and it'll run for 30 years. Okay? We're going to and then the other assumption is at the end of 30 years we can't get anything for this. In other words, if this were a business, we can't sell it to anyone. We're just going to assume it's going to be closed down. Okay? And we're going to use a discount rate of 5%. Now, the discount rate should represent the expected rate that investors in this business or this opportunity project, whatever it might be, it should represent the discount rate or the rate that those investors expect to get on the next best alternative of comparable risk. Okay, so in this example, it's a very low 5%. And then what you have to do is calculate net present value. Now, I've done it for you here, but here, let me show you how we do that. We type equal NPV into Excel, hit the left parenthesis, and then what I typically do is come up here and hit this insert function button. It gives me a pop-up screen. It looks like this, and then it wants to know where's the rate. Well, there's the rate, and then you have to tell it the value, but pay attention here. It says 1/254 equally spaced in time occurring at the end of each period. Now, what that means is we can't include the first period. So we'll go up and we'll point to where that first period is. Let me move this out of the way. So we don't include period 0 because it has to start at period 1. And then you can just hold it down and scroll till you get all the periods in there. Okay? And when I do that, we're going to first get the wrong answer. Okay, I'll show you the pop-up. The pop-up comes up with this number. That would just be, let me slide down so you can see it, that's just the present value of the future cash flows. So from there, we would have to subtract out the initial cash flow. And if you entered it as a negative number like I do, then you have to add in the negative cash flow. Okay? So given this example, the net present value comes out to be $973,700. Now what that means is if you invest in this project in today's dollars, you are increasing the wealth of whoever owns this project, right, by $973,700. All right, now a project like this that has such a high return may have a higher risk. So maybe the 5% isn't accurate. Well, what if that 5% was, say, 10%? You'll see that it drives down net present value. Okay? That's something to keep in mind. Now, what if instead our projections were too high, and instead of starting off with $15,000 and increasing by $5,000 a year, what if it only increased by, let's say, 1,000. So here we have about 974,000 is the present value, assuming a 5% discount rate. What if instead we made this to be 15,000 the first year, and then every year it just increases by 1,000? Okay, so if I do that and then copy this down into all of those cells, all right, what we would come up with is a much lower present value. And then, of course, if the discount rate was 10%, then the net present value goes even lower. Now, eventually, the discount rate will make this opportunity look poor. Like, what if the discount rate was 20%? What if, I mean, this is very high in today's interest rates, but what if this is so risky that the only people you can get are people that want, that the only people that you can get to invest in this want a 20% average return on their investment? Okay, if we do that, what we see is net present value goes negative. Now, what that means is that if you take on this project and your cash flows that you projected turn out to be true, you actually are decreasing your wealth by $1,053. Okay, so let me back this all off to where we had the original one, and I'll stop here. So here's 15,000, it increases 5,000, the discount rate is 5%, and the end result should be, not 55%, but 5%, should be a positive net present value, and we don't care about pennies in this example, by $973,700. And that's this problem, everyone.